All right, this worksheet is called the AA Similarity, Side Angle Side Similarity, and Side 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 Similarity worksheet. And the front page is just getting you used to identifying which one of these three could be used to prove two triangles similar. So we're going to be writing kind of like an informal proof. And then the second page is a full proof and solving for x using a proportion once you prove them similar. So first page, just identifying, second page, true proof and using the proof, the similarity, in order to solve for the proportion. So here we go. How can I tell if something's going to be angle-angle? So just looking at the first three examples, A, B, and C, if I'm looking to use angle-angle similarity theorem, I'm looking for a picture that has two angles marked in the triangle. So for example, here it has a 40 and here it has a 40. And here it has a 66 and I don't know what's over there. And here it has a 78 and here it has nothing. So before we can decide if these two are similar by AA, I need to subtract 78 and subtract 40 to see what this third angle is and see if I even have two angles. So 180 minus 78 minus 40, grab your calculators and do that. And I'm getting 62. So 62 degrees means right in here is a 62, but I wanted a 66. And on this other one, 180 minus 66 minus 40 gives me 114. Sorry, 74. And so I get a 74 over here, I get a 78 over there, I got a 62 over here, I got a 66 over here. There are not two angles that are congruent. Therefore, the triangles are not similar. So we could have used AA if we had two triangles, but here we don't, so we say they are not similar. Okay, but how do I recognize that it could have been an AA? I'm looking for those two angles. Okay, next one, I'm looking for SAS. Between A and B, which one would be SAS? Notice there needs to be an included angle in between two sides. And notice right here, we've got an included angle. So you're right, B is what we would use SAS for. Let's see if it actually fits. So first I've got this side corresponding to this side. So let's write up a little proportion, a little ratio for that, sorry. So we're gonna say DV is to BN. So that's 20 is to 4. And then we're gonna go for the other corresponding side. VA is to NE, or 25 is to 5. Both of these reduce down to give us 5, and as long as the corresponding side ratios are equal, then those sides can work for my similarity. Now we also have angle V is congruent to angle N, so that's the other piece that was given in the picture that works for this. So I do have similarity by SAS similarity theorem because I have a side and another side that have ratios that are equal. So we're going to write ratios of corresponding sides are equal. So those two sides with the same corresponding side ratios that are equal and the angle that was given is enough for side angle side. So I could say triangle DVA is similar to triangle BNE by side angle side. All right, for this first one, that just leaves us side, side, side. Let's go see if it makes sense. So notice that I've got this side corresponding to this side. It's in the same place. And then I've got this side corresponding to this side, and this side corresponding to this side. So let's write up those side ratios and see if they're equal. I'm going to go blue side first. IE is to FR is a 12/4. That reduces down to 3. And then I'm going to do the yellow side. ER is to RA is 21/7. Also a 3. And then the green side, RI is to AF, 24 is to 8. And so notice that on all three, I have that ratios of corresponding sides are equal. They all equal 3. Your letters can be reversed, but one thing that you want to stay consistent on is if I go big is to small for my triangles, I need to stay big is to small on all of my ratios. If I go small is to big, I could have had all of these reversed and gotten 1/3, 1/3, 1/3, and then all the side ratios would still be the same and it would still work. But so please make sure you are staying consistent with big is to small or small is to big. So this is similar by the side similarity theorem, since all three sides have the same ratios. So we say triangle IER is similar to triangle FRA by side. Okay, now that we've seen an example of each, let's go through and see what we have here. So I've got angle A congruent to angle E because all right triangles are equal. And then I've got two side ratios. IA is to FE. And then SA is to RE. These both reduce down. 5 goes into 10 2 times. 5 goes into 25 5 times. 2 goes into 4 2 times. 2 goes into 10. Both of these have a side ratio of 2/5. So I've got an angle and two corresponding side ratios that are equal. So I can say that I have enough for similarity by side angle side similarity theorem. So triangle SAI is similar to triangle REF by side angle side similarity theorem. How'd you do? All right, this next one over here has 3 sides. So I'm going to highlight which ones I consider corresponding. So those two go together, these two go together, and these two go together. All right, let's try it out. I'm going to start with the pink side. WA is to SA. 60 is to 15. Next, I'm doing green side. WO is to SN. Also a 4. And then the blue side. OA is to NA. Also a 4. I have ratios of corresponding sides are equal. So I have enough for side similarity theorem. So WOA is similar to SNA. All right, on this next one, you have to know about these sneaky little vertical angles. So then you have a side angle side. So I can say WN is to HN. That's these guys right here. And that would be 7/35, which is 1/5. And then I'm going to go the other side. I'm going to say IN is to DN. So that's 6/30, which is also 1/5. I've got the two side ratios. All I need now is the angle. Angle WNI is congruent to angle HND. And that one's by vertical angle theorem, where vertical angles are equal. And this guy right here, we write ratios of corresponding sides are equal. I've got enough for similarity by side-angle side similarity theorem. So WNI is similar to HND. What is wrong with my ends? Sorry, guys. Sorry. Okay. G was sort of a tricky one. This angle is not included between the two sides. You cannot do side angle side, so similarity, not similar, unless the angle's in between. Oh, hang on a sec, sorry. The angle's not in between on either, so let's go relook at this. But the same thing applies. We can't use side angle side unless it's the side, that's in between both. And so notice right here, we know nothing about angle L. We know nothing about angle E. So we cannot use side angle side without that information. So the answer for letter G is not enough information to prove similarity. Okay, so it's kind of a tricky one, a fake out, if you will. All right, let's look at the next one. Next one, we've got sides, but let's do the whole side. What's 10 plus 8? That's 18. What's 12 plus 15? That's 27. And then we've got this little included angle right here as well. Angle T is equal to itself by reflexive property. All right, so we've got an angle. I wish I had a side on either side. Oh, I do. Let's go do it. All right, so we're going to say small is to big. So I'm going to say HT is to IT, or 10 over 18. And then I'm going to say OT is to BT, or 15 over 27. So we need to reduce these and see if they are in fact equal, because I can't tell when they're like this. So what goes in? 2 goes into 10 5 times. 2 goes into 18 9 times. 3 goes into 15 5 times. And 3 goes into 27. Oh, look at that. Ratios of corresponding sides are equal. So I can use side angle side similarity theorem for this. Okay, triangle hot and similar to IBT. All right, last but not least, this one's a little bit reflected, so you got to be careful, but check this out. This goes to this. This goes to this. And this goes to this. Let's go see if they're equal. 6 compared to 4. 22 compared to 11. Anyone noticing anything yet before I do any work? 22 over 11, 6 over 4. These are not the same side ratio. So triangles are not similar. Very, very sneaky. How'd you do?